Hello everybody! In the previous lesson we learned about the function templates. Today we are going to learn about the class templates. Yes, exactly. We have the same thing in classes and it's really needed many times. So let's see how does it work. As you can see here we have the code also from the previous lesson and we'll create now the template of class. How to do that? Well, we type here template, so it's the same like in the function templates. Then we are typing here something like type name, then name of our type, so something like that, or we can just type here T. And now we've just created a class template, but of course we need to specify all that T's here. So I want to change all the integers here to T. And right now, when somebody create a point class, every T will be changed to the type that he will choose, right? So we will be able to create a class of doubles, a class of integers, and other types. Okay, but now I would like to tell you that unlikely we will need to use the namespace in that place. Also, we'll need to include the IOString here. And we'll also need to copy all the functions from here to here. So definitions must be in one file because that IDE won't be able to refer to the things from that file here. So, well, that things here will get into the command. That thing here also will be commented for a moment because we focus on one class first. And let's now define the functions here. How to define them? Well, we need to in every time repeat the template and type name T before each of the function, right? Then we need to remember that we need to add something like that each time. And of course, we need to change the integers to T. Remember that we can create here easily now, for example, the character B, something like that. Everything will work fine. So it means that this variable will be in each object that we create by using the template class will be character. So it won't be changed, right? If we did it that way, it will be changed. But if we do it that way, it won't be changed at all. Okay, so we will right now can just remove this. Okay, now let's go back to that place here. And let's create that point A that is equal 5. Let's see if everything will work fine. As you can see, it is not compiling. It's because when we are creating a template, we need to specify that T here. We have to specify that. So I'm going to create the point of integers, for example. Now I can build and run that program. As you can see, everything is working fine. We can send to the output, for example, the value that is in X easily. Let's see if it works. As you can see, everything works fine. And I would like to remind you, you have to just specify that T in places like that. Okay? But you don't need to do it in places like that. So, for example, here where I am returning, well, where is the getX? Here is the getX, right? We can return always integer, for example, right? And everything will work fine. We can always return the double. And it will work fine. We are deciding what type will be here. But of course, right now, we want it to be the T. Because we want to change it in every place. But sometimes there might happen that you will need your own type. And you will want it to be like that. You don't want it to be changed from place like here. Okay, so as you can see, this is working fine now. So let's maybe talk about something what is called the type definition. You see, we can do something like that. We can do that thing. Type definition, then we can say point, int, and now please just think about it as a point int. Now we can define variables that way. So right now this thing means the same thing like this. I know that it is not very time saving or something like that, but maybe you will notice something like that in code, and I want you to know what does it mean. Okay, so now everything like that will be changed to something like that. We can do something like that. Well, maybe something like that, and it will work fine. Okay, so this is the type definition, and well, I like to also show you that you can still create the double things. So right now that thing will be double. Let's see if it works. Everything is working fine, as you can see. Okay, so now let's define maybe that things here, right? We need also the class point to dimensional. You will do as an exercise. You can do, you don't need to, but it's a good idea. You can do as an exercise point 3D. And now let's just create a template of it. So template, and now type name, and we'll call it T. And now we need to remember that we need to send that T to that place here, because we need to know in the subclass how to create the the parent class, right? In the child class, we need to know how to create the parent class. So we need to send what type should be of that things here. Okay. Then of course we should change that things. We don't need to, but we should, because we want them to look like that. As you can see here, we have the point to D returned, and we are not changing that to T. This is the type that we want it to be here, right? Okay. And now of course we need to copy that things from here. Let's cut it and let's copy it. Now let's do something like that. I know it's time consuming right now, but remember later, if you want to use it in many situations, like in point, because points might be double, might be integer, that will be easier for us, right? And you know that point of doubles, the class point of doubles, is taking more memory than point of integers, right? Okay. So now let's change where we should, or where we can, that T. Let's change it. Oops. Like that. And now we also need to remember about adding that T here. Like that. So, okay. And I would like to also add that you need to add the point T here, because you know you need to we are using the constructor here from the class here, and it means that we need to know what is that T here, right? Okay. And we also need to say about it here, because well, we are returning something and we need to know what type is it. We can add it also here and here, but it is not needed, because our compiler is intelligent. He will somehow manage out by that line here what is that T here. Now I can build and run that program. As you can see, it compiled. Let's maybe now create the point two-dimensional, and now, for example, like that. That thing, let's comment it. And now let's build a rounded program. As you can see, the result is 10.5, so it works fine. And everything compiled. So now you should create the point 3D as an exercise. There might happen situations, maybe not with that class, but I will show you on this class, that you want the specialized template class. So it means, hey, I want to make a point class that will behave a bit different when somebody sent here a type that I choose. So, how to do that? Well, let's do it, for example, here. And now we are doing it that way. Template, and then, like in the functions, we are not specifying anything in the angle brackets, right? Then we are saying name of class that we want to specialize a bit, and then here we are saying, hey, I want it to be character. And now we can, for example, create here in the public section the constructor, right? And let's send to the output something. This is from well, sorry, not punct but point. This is from point and character, like that. Let's see if I can compile it. As you can see, everything is working fine. And now we can create that point, for example, like that. Character, and now here I can send, for example, 49, but well, character, and let's call it somehow A, and by default we'll assign here 0. So now let's just build a rounded program. As you can see, it is working fine. This is from point character. So now when our compiler sees something like the character sent here, no, this class is not being created, but the specialized one, this one is being created, right? Because we want to behave it a bit different. Notice one thing. Right now, can we get something like bGetX? As you can see, that that class do not have that function. So right now we need to define everything in that class. This is just special case, and we need to define everything from the beginning. This special case for character, okay? It must behave different way. Okay, so this is the specialize of the class, but we can also do something like specialization of just one method. For example, I want, let's go getX to behave a bit different. This guy, right? I want it to behave a bit different. So in some kind of situation. So I'm going to do something like that. Template. Then, of course, I'm not specifying anything in the angle brackets. Then I am just creating that getX. So, for example, for the double point, double getX. So right now we can return this X here, right? But it will work only for double situations. So when I send something like that, this function will be executed only when point double is being created, right? So this is the special case when people create it that way. I think it's not working because we have got here an inline function. Let's change this thing to not inline function. So let's create before it to get x. So get x, and we are returning the t. Return this x. So this is the default function, right? And this thing is the specialized function for template. Now it should work fine. I stopped the program for a second because I was a bit confused why that error was here, and then I just removed that point CPP from the project. Looks like when you are creating templates, you can't even have the CPP file because he's compiling sometimes 2 times something when there are templates. Well, templates are making some problems when there is the point.h and point.cpp. So let's just remove the CPP from the project, and now as you can see, this is running well, right? It got our program is running, and as you can see, this function will be executed only when point double. So this function got executed, right? So a good one. And I do it that way. So when I don't want the specialized version of that function, as you can see, we invoked that function here, right? That function got invoked. So now we can specify only the function. So it's, I think, a bit better than this thing here. This thing is very rare to use, but specializing the function, I think, might be used many times when you're doing something like that. Now I'd like to tell you about the half class specialization and when it is a good idea to use something like this. This is a bit advanced topic. Look, we can do something like that. So the template, and now type name, and here the type that we want to create, want to have here. So we can name it as we want. We can name it t, key, anything like that. I will now call it key, so it will be different, just so you know that you can name it different. And now here I'll create a class point that will take that key here, right? And in addition to this, I want it to be the pointer. It must be the pointer. So this thing means that when somebody will use here something like that, I want compiler to create that class here, not that class here. Okay? And when it's a good idea to use, because right now we can say something like, hey, you just did it. So we will send to the output something like that. You can't use pointers here. So right now, well, we need to specify something here. So if there is a key, I equals 0. Sorry, it should be point. Sorry, I wrote the point in our language, in my language. Okay, and here right now, of course, we can't get x because it's impossible, right? We can't use pointers here, so now we are informing that you can't do it here. That class is running, right? That class got created. And of course, we couldn't use that function here because that function, the getX, is not doesn't exist, right? And that's how it works. This is a very advanced topic. It's very rare to use, so don't worry about it. I think the most important thing is to remember about the specialization of function from a class, like that getX that we created here. I know that that we didn't change much here, but it is a useful thing. Okay, that's all in the lesson. Thank you very much.